So the current version is 1.7, so when you request bootstrap.js, the first time, I'm just going to return a 200 response. But instead of making it cacheable for only an hour, I'm going to make it cacheable for a year. I think that's a year. And now the Bootstrap will execute, and it will send this beacon or make an XHR or do a JSON or something like that. For some other, and in the case of a beacon, instead of it being an image, we can just make it a JavaScript file, right? Instead of an IMG, new image, I can do document create element script. And it will send over this information, including the version of Bootstrap, and the server can say 204, no response, right? Hey, you got version 1.7, everything's cool, you're up to date. Now, the next day, tomorrow, since I've made Bootstrap cacheable for a year, instead of 15 minutes, so now I reduce the probability of front-end spoof, because now, since it's cacheable for a year, this user's browser just reads it from the cache. And there's no request for bootstrap.js to the server. But I updated to version 1.8 last night. So the user is actually out of sync right now. But then the bootstrap.js executes. As part of its execution, it sends this beacon.js, which says version 1.7, because that's what's in the cached version of the script. And the server says, instead of 204, no response, says, oh, okay, well, here's some JavaScript I'm going to give you back. I want you to create a hidden iframe. And in that, I want you to request this update page, which is on my server. And when you request that update page, I'm going to return this JavaScript synchronous script for bootstrap.js. And since this is a hidden iframe, it's not going to block the page at all. It's loaded after the Bootstrap has already started. And then it's going to have this other cute little snippet, which basically reloads the page once and only once. Now, what happens when you reload a page is instead of sending an if modified since conditional GET request, it sends a plain GET request. There's no if modified since, if none match headers. And what's going to happen when you do that is the server is going to return a real version, the new version of bootstrap.js, version 1.8. And there's another thing that it does that's more powerful that I'll get to next. So the page reloads. It's read the first time that update.php loads, it loads bootstrap.js, and it loads it from cache, because it's in the cache. But then the reload happens, and the next time update.php gets loaded as part of a reload, it requests bootstrap.js, and it's not a conditional request. And even though it's in the cache and it doesn't expire for another 364 days, since I did reload, it's going to re-request it. And it's going to get the latest version, and it's going to store it in cache. It's going to overwrite the old version 1.7 with the new version 1.8. So, voila, we can have Bootstrap scripts, and instead of having to have a short time, which increases the chance of front-end spoof, we can give them long cache times, and we can use this self-updating pattern to get the new versions automatically in the background. The one caveat is that new version is going to be used the next time the user hits the page. Is that super bad? Most of the time it's not. And in fact, that's the way app cache works. So, but it is something to consider. If there was no way that you could ever tolerate someone doing even one page view with a script that had been updated, then you might not want to do this. But there are a lot of cases where it's a perfectly good pattern. Here's Philip Tellis, another former member of the Yahoo Exceptional Performance team. He's at a company now called LogNormal that just got acquired by Sosta. But what they do is they do this RUM, real user monitoring. We'll put a script and measure how long your page takes to load. And they do that for a fair number of sites. And he saw this self-updating pattern, and he said, I know we have right now, when people load our lognormal.js, they beacon back the page load time, and when we get that beacon, in it we have the version of the JavaScript file. And even though our JavaScript file is only cacheable for a week, we're still getting beacons from the script, the version of the script that's 4 months old. Why? Well, there are a lot of intermediate proxies that are just misconfigured out there. There are a lot of machines, for whatever reason, every time you reboot them, they go back to epic time, 1970. And so this expiration time, depending on how you've specified it, like if you did it with an expires header that is, October 2012, well, it's going to be 42 years before that goes out of cache, right? So this is, and you'll notice this, anyone who's pushing stuff out there and you update it, a script, for example, you'll find single digits, 1 to 5% of your users are never getting the updated version. So what he found was when they just did the normal way of having it expire after 7 days, the version from, I think, last April, they still saw about 5,000 beacons from that old version during this week in June. And then he rolled out the self-updating script pattern, and it dropped to 600, a 90% drop. So this is another benefit. Not only can you set a longer cache time for your Bootstrap script, forcing this reload bypasses these misconfigured intermediate proxies or other anomalies that are keeping expired content in the user's cache regardless of what you've set the headers to. So that's very cool. Okay, now I think this is the third and last one, and this was the one I was hoping Doug would appreciate. A long, long time ago, I used to write C code and C++ code. This was like in early 2000, 2001. And we had this very dynamic, loosely coupled architecture where we had a lot of DLLs, dynamically linked libraries, and we loaded them manually. We didn't link them into the executable. We loaded them on demand depending on what the user was doing. And we used these two functions, dlopen and dlsim, to do that. And basically, we have some symbols. We don't know what it is we want, but on the fly, we'll load these symbols from wherever. And we want to be kind of cautious about how we do that. So we call dlopen, and guess what? It returns a value, and we do error checking on it. And if it fails, we exit. And there's actually some better error handling code in there. I stripped it out for the case of readability. And then if we want a symbol in that library, we do dlsim. And again, we can check if there was an error trying to get that symbol. Let's look at how we do basically the same thing in JavaScript. I'm going to do script source for some JavaScript file on my server, and then I'm going to start calling it. In this case, maybe I've created a combo JavaScript file that includes jQuery. I'm not going to test the OnError handler. I'm not going to test if the dollar symbol or mouse down symbol exists. I'm just going to let it fly. What? Are you kidding me? Like, maybe on some toy site you would do this, but this isn't hardened code. And yet, how many people here on your production websites have an OnError handler for all your scripts? I don't. I don't think I've ever written, captured the OnError unless I was doing some kind of experiment on OnError. Yeah, we'll just assume everything loaded and start calling these symbols that were in that thing that might have failed or timed out. That is just amazing. So, one thing you can do, and one thing you should do, is you should add an OnError handler for all your scripts. And you might not want to check every symbol of a library, a JavaScript library, before you call it, but you might want to check at least one or two and make sure that everything is actually hunky-dory. If you track the OnError handler, you probably don't need to check a symbol, but you could. Here's another way to solve this, which I think is very elegant. John Resley blogged about this 5 years ago or something like that. He called it the degrading script tags pattern, where, here, actually this is a more readable version of it. Here's the example we had before. Now in this case, instead of having a synchronous script and then another inline script block that will be executed regardless of what that external script does. I'll use the degrading script pattern. And I'll put that code that depends on the JavaScript file within the script block. There's only one problem with this pattern. It doesn't work in any browser. But that's not a big deal, right? We're JavaScript programmers. We can fix that. So at the end of this JavaScript file, it can just iterate through all the script tags in the page, find the one that belongs to it, and look at the .text property and execute it, eval it. Eval's evil if you don't know what the code is, if you're pulling in third-party code. But in this case, if you know what the code is, then it's your code that you wrote and you're putting on the page. I think it's fine. From a performance perspective, eval is fine. So this pattern actually works. It works in every browser I've tested. I wrote about it years ago, and it really hasn't caught on. But we need to do something. I think this is a really elegant pattern. If there are various reasons why it might not work. You might be loading jQuery or stuff off the Google's API that you can't add a little snippet of code to at the end. So then you could use an OnError handler. But we got to do something. Because, let's face it, we're JavaScript. And we mean business. Thank you.